So welcome students to Factoring Special Cases, Sum and Difference of Cubes. So we learned about difference of squares the other day. Now we're going to learn about sum and difference of cubes. If a polynomial looks like something to the third power plus something else to the third power, or like something to the third power minus something else to the third power, then it's called a sum. So that's the sum, or difference. There's the difference of cubes. So sum of cubes, because it's a sum, an addition of two cubes, or a difference of cubes, because it's a difference or a subtraction of two cubes. And that's what these are going to look like. And for ease, you may want to remember that a squared is a times a. Sometimes it'll be easier to think of it that way. This, of course, is a times b. And this, of course, is b times b. So don't get into the trap of doubling these when it says square. And then I just want to put up here for reference, and I highly recommend you copy it. 1 to the third power is 1. 2 to the third power is 8. 3 to the third power is 27. 4 to the third power is 64. 5 to the third power is 125. And 6 to the third power is 216. You could always figure these out in your calculator, but as you work through the notes in your assignment, it's going to be quicker if you can just reference this. So let's look at an example. Dive right in. So we want to factor x cubed minus 27. Now these instructions are going to be a lot like the difference of squares instructions. We're going to rewrite our polynomial in a certain form. So I want it to look like something to the third power minus something else to the third power. So x to the third power is easy. It's obviously x. But 27 is a little harder, and that's why I recommend that you have this here, because you can just look. There's 27. Well, 27 is 3 to the third power. So then I've got it written in the correct form. Then you want to identify your a and b. So we're here. We're on this form because it's a difference of cubes. And your a, in this case, a is going to be x, and b is going to be 3. So I got my a and b. Then I want to write the factor as shown. So I'm going to start, my first factor is going to be a minus b. So in this case, that means x minus 3. Then my second factor is going to be a squared plus a times b plus b squared. So a times a plus a times b plus b times b. So let's do that. A times a. So a is x, so I'm going to take x times x, which is x squared. Then plus a times b, so x times 3, which is 3x. And then plus b squared, so 3 squared is 9, so plus 9. So there's my factors right there, and remember to check with box method. So let me check that. Now just be cautious, your box, when you multiply these, you're going to have to put 3 boxes along one side to accommodate this, to accommodate the quadratic factor, and then your linear factor, then your binomial. All right, so x times x squared, well, that's x times x times x, which is x to the third power. Then x times 3x is 3x squared. X times 9 is 9x. Negative 3 times x squared is negative 3x squared. Negative 3 times 3x is negative 9x. And negative 3 times 9 is negative 27. Now watch what happens along the diagonals where we have like terms. So 3x squared and negative 3x squared are like terms, but they cancel each other out. So just like when we did difference of squares and our like terms canceled out, same thing's happening here. And then 9x and negative 9x, they're like terms, but they also cancel out. So all that leaves us with is x to the third power minus 27, which is what we were factoring in the first place. So that means, yay, our factors worked. We got it. So I'm going to have us do together 2 and 4, and then you're going to try 3 and 5 again. So let's try. So first step, rewrite in a cubed minus b cubed form if necessary. So I want this to be something to the third power minus something else to the third power. So let's consult our reference chart, because the x part is easy. X to the third power is obviously x to the third power. But what about the 8? Well, 2 times 2 times 2 is 8. So that means 2 to the third power is 8. So I'm going to put a 2 here to take care of that. So 2x to the third power is 8 times x to the third power. And then the 27, well, we did that one before, so we know 3 to the third power is 27. Then step 2, identify the a and b, just like we did here, just like we did for difference of squares. So a is 2x, b is 3. And then step 3, write the factors as shown above. So I'm going to start with a minus b as a factor. So my factors, let me write that. My factors, 2x minus 3. So my first factor is 2x minus 3. And then my second factor, I'm going to start with a squared, so a times a. But my a is 2x, so 2x times 2x is 4x squared. And then plus a times b. So plus, and then a times b, so 2x times 3 is 6x. And then plus b squared. But b is 3, so plus 3 squared, which is 9. And there's my factors. So go ahead and check your work, and then come on back. So I've checked my work, and notice again that the like terms on the diagonals cancel each other out, leaving us with 8x cubed minus 27, which is what we started with, which means our factors are correct. So then let's look at example 4. So example 4 is a sum of cubes, but the only thing that changes out of this whole procedure is that these two signs are different. So this one and this one. So before when we had subtraction and addition, now we're going to have addition, subtraction. It's the only difference. Otherwise, it's the same thing. So 64 y to the third plus z to the third. So we still want to rewrite it in this form except with a plus. So I want to rewrite it as something to the third power plus something to the third power. So let's take care of what's easy. Well, z to the third power, that's obviously a z goes in there. And then here, obviously I want a y there because of y to the third, but what about 64? So go up to your reference chart. Well, it looks like 4 times 4 times 4 is 64, so 4 to the third power is 64. So I should put a 4 right here. Cool, so I got it written in the right form. Now I identify the a and b. So a is going to be 4y and b is going to be z. And then write the factors as shown above. So factors. And then since this is a sum of cubes, I want my first factor to be a plus b. So a plus b, first factor. And then my second factor is going to start with a squared, so a times a. So 4y times 4y is 16y squared. And then minus a times b. So minus a times b, so 4yz. And then finally plus b squared, so plus b times b. So plus z squared. And there's my factors. And then go ahead and check your work in this tiny space you have left and come back. So I've checked my work, and I notice again that on my diagonals I have like terms here that cancel out, so negative 16y squared z and positive 16y squared z are like terms and they cancel. And then along this diagonal I have 4yz squared and negative 4yz squared. They're like terms and they cancel. And that leaves me with 6y to the third plus z to the third, which is what I started with, and that means my factors are correct. So you try 3 and 5, see if you can pick the right answers, and then continue the video to check your work. So here is the solution in full, including checking, and notice that as usual your diagonals cancel each other out. And so go ahead and fix anything if it needs to be fixed. Thanks for watching.